Unions of events, part 2. If the probability of A union B equals 0.6, the probability of A equals 0.4, and the probability of A intersection B equals 0.25, find the probability of B. Assume that A and B are events. We're going to use the union formula. The union formula says that the probability of the union equals the probability of one event plus the probability of another event minus the probability of their intersection. So we'll just take the numbers that are given to us and plug them into the formula. We're told that the union is 0.6. The probability of one event is 0.4. The probability of the other event is what we want to find, and that's P, or the probability of B. And then we're subtracting the probability of the intersection, and we're told that that is 0.25. Okay, so we want to isolate the probability of B. In order to do that, we can combine the 0.4 and the negative 0.25. 0.4 minus 0.25 gives us a value of 0.15. So the right side of my equation equals 0.15 plus the probability of B. And then on the left side, we have that equals 0.6. Now I'm going to isolate the probability of B by subtracting 0.15 on both sides of the equation. 0.6 minus 0.15 gives us a value of 0.45, and that equals the probability of B. And that is my final answer. The windshield wipers on a car have not been working properly. The probability that the car needs a new motor is 0.65. The probability that the car needs a new switch is 0.45. The probability that the car needs both is 0.15. What is the probability that the car needs neither a new motor nor a new switch? First, I'll write down the pieces of information that are given to me. Now, I'm given the probability of one event. We'll call that the probability of E, which is the probability of getting a new motor. And that probability is 0.65. The probability of the second event, which is the probability of needing a switch, is 0.45. Then the probability of the intersection, which is the probability of needing a new motor and a new switch, is 0.15. If we look at the things that are given to us, we have most of the pieces of information in the union formula. So I know that I'm probably going to need to use the union formula. Now the union of the two events is the same thing as finding the probability of either getting a new motor or a new switch. Now if we go to our problem, we want to know the probability that the car needs neither a new motor nor a new switch. So this neither is really the opposite of the union. So the opposite of either a motor or a switch is neither. So what I really want to find is the complement, which is the opposite of the union. So this we can represent as the probability of the complement of the union. In order to find the complement, which is our end result, we first need to find the actual probability of the union. So to do that, we're going to use the union formula. I have the probability formula for the union on the screen. And I'm just going to substitute in the probability of the motor, the probability of the switch, and the probability of the intersection, or the probability of both, into the formula to solve for the union. So P of E union F is what I'm trying to find, and then the probability of E, which is the probability of the motor, is 0.65. Then I'll add that to the probability of the switch, which is 0.45, and then I'll subtract the probability of both happening, which is 0.15. 0.65 plus 0.45 is 1.1. And then 1.1 minus 0.15 is 0.95. And again, this is the probability of either motor or a switch. Okay, like we said before, we want to find the opposite of the union, which is the complement of the union, because we're asked to find the probability of the car needing neither a new motor nor a new switch. The probability for the complement is just 1 minus the probability of the event. So this would be 1 minus the probability of E union F. We know that the probability of E union F is 0.95. So we'll just take that value and substitute it in for the formula for the complement. And then when we do 1 minus 0.95 on our calculator, we get 0.05. So this is the probability of the complement of the union. And this probability represents what we're asked in our problem. So 0.05 is our final answer.